Exactly.
Okay.
Correct.
If it is tweeter or as frequency goes higher, it will be like this. So you can actually reflect once.
Yeah, reflect more.
So the reflection actually adds to the intensity.
Correct.
It gets support. Okay. So what happens is as the frequency goes higher, that content will be more pronounced due to the reflections on the baffle. So we need to attenuate that. Okay. The attenuation is more required on the mid woofer. Tweeter you don't need to. Tweeter you can level matching is sufficient. So this is actually happening in the same driver. That is why we need to give an attenuation magnitudes here. But in this case, both will not happen. Everything will be.
How is this baffle step correction done? What is
this is the baffle step correction circuit. It consists of an inductor and resistor. Depending on the width of the baffle, there will be a frequency. You get a baffle step from which the step occurs. So we can actually, there are formulas. We can share it as a follow-up of this forum. You can, this quarterwave.com, Martin J. He has a very good explanation.
But the baffle step is not used in most of the speaker designs, regular speaker. Only
this is actually a
so
good
baffle step
crossover.
is an option.
So,
okay.
Anil, you're using baffle step correction only to attenuate the high frequencies that are approached.
Because you can change the resistance by which you balance the bit output. It's basically an equalizer, acoustic equalizer. So it gives a lot of way to tune the sound according to your. Most of the full range designs will have baffle step because there is no other way to control the mid. This is the only equalizing possible. And then it comes to the impedance correction of the drivers. Impedance correction is that peak. Whenever there is a peak, you have to attenuate this peak. You have to derive. There are some LCR circuits in which for the woofer it is it's called as also known as Zobel networks. It is a derived one according to the woofer's driver's impedance. You derive at the formula and you have to include that. And so there are advanced
impedance curve is if it is more or less linear, is not required. Right?
Impedance curve is never linear.
So wherever it is peaking, you need to add those for those frequencies. You need to suppress it.
Why are there so dips and all this? Certain frequencies here is dipping. Why is it that happening?
It is the driver's impedance curve will have a peak normally associated with it. I think I can show you that.
No, in that graph, that faint line is a cone breakup, is it? Those frequencies.
See here, this is a cone breakup. Small dip there. There's a small dip here. No? There's a small spike that is associated with the. Actually, what happens is it will actually give less resistance. So that means that impedance. What happened? That impedance is applicable here also. In a little.
Another peak.
Another peak.
Can you go back to the chart? The line.
Off-axis response.
30 degree.
Okay, now the ready-made crossover. You get ready-made crossover available. Ready-made crossover obviously can have only these two sections.
Low pass and
yeah, low pass because this is all these relating to driver and enclosure. So once you have this, you can try. You can upgrade it. You can measure the driver, add on a baffle step correction, add on impedance correction, add on level matching. It is separate. That is possible.
Let's say you're using active crossover. Active crossover is the green thing.
This is not active, this is passive. Passive.
You can do it actually. All of them are possible. All of them can be done by active crossover. Like D if you
okay. Now this is on passive crossover. Everything usually use use MPP. These are locally available MPP caps which are available in SQ road, and they are very good. Really. This is not CTR. This is called Filcon. I measured with Keltron. They are much more consistent.
Polypropylene or polyester.
I think it's
polypropylene.
Yeah. And they are very, very good. As good CTR is also available. CTR is actually supplying to defense. So you can understand it is a very good quality. They only give to defense.
Which one CTR?
CTR. They come the same color, yellow color.
So available in
and then you have this normal, this is known as fusible resistors. These are non-inductive types, but when you go and ask, you have to ask fusible resistors. That is what the trade name is.
what this is?
Fusible resistors. And this is fusible resistors are basically used in the baffle step correction and the woofer circuits. And the power rating, you always aim for at least 15 watts or more. So that's why I have actually combined 4 of them to get the desired power rating. And for the tweeters, we use the metal oxide resistors. See, these are the metal oxide resistors. I could only get 2 watts. So I used 5 of them. So just calculate the parallelly, the combination, what is the resistance you needed, you can do that. And there is another, this is the polyester capacitor. If you are not using MPP, you can, like when you have to add combined values, you can use polyester capacitor also. This is Philips is available. Korean Philips. Now I think Philips is. This is also available in CP Electronics if you want to know the shop. I bought all these caps and resistors from CW Electronics next to Vishal. But I think CTR is available in Amar. Then once you can assemble the crossover in any piece of a plywood or a hardboard anywhere, you just have to, what you need to consider is mainly the placement of inductors. There is inductive coupling. Like once, when all the inductors are in the same plane, see, it will couple and it will affect the resulting inductance. Suppose it is say 0.5 mH, you have a 0.3 mH next to it, it will affect, and it will not be 0.5, it will be 0.4, might be 0.6. It will vary.
You cannot shield it, is it?
We will change put these things in a different plane. This is in this plane, this is actually 90 degrees. 90 degrees is the